to lab number 2 first. So if you would please, let's go to number 9, because I want to make sure you know how to do word problems with a sine and cosine, because this we've done some, but this is good practice. All right. So I have a population of animals, and it oscillates between a low of 1,300 as of January 1st. This is when time is 0. And a high of 2,200, sorry, on July 1st. And we're going to let t equal 6 for that. So I'm just kind of looking at that. They said sketch a graph of the function for a 2-year period. So first thing I do, this is my sketch. So here's A, is make this bigger than your pinky. I gave you a whole page, and they want 2 years. Okay. So notice I'm just doing it in quadrant 1 because they're talking about animals. So life is in quadrant 1. Okay. This is my population in numbers, and this is T in months. Okay. So now what I'm going to do is kind of do my own sketch. Now you don't need to show a break in the graph unless I actually give you graph paper. Because this is my sketch, I can put my numbers kind of anywhere I want. So this is 0. I'm going to call this 1,300 right here. And right here, I'm going to call this 2,200 because this is the 2 numbers they gave me. And then I'm going to start, they told me that the January 1st time was 0. So I put it right on the y-axis. Please never shift it over, because if you do, then there's a shift in your graph and your formula will be wrong. So I'm trying to make this easy for you. January 1st is time equals 0. It's right on the y-axis. And then there's 6, 12. We're going to do 2 years, 18 and 24. So we're doing 2 years, so there's 24 months. They said the low was 1,300 on January 1st, so there's the low. The high is on July 1st, so this is July 1st. Okay, so here's my high. And then we're going to come back down to January 1st, the next year. That's when it's 12 is our low, high, low. I mean, literally, that's what I do. Okay, now I'm going to swing a nice curve through here and see how good I am. All right, there we go. Now, on a quiz, I might ask you to do 1 year, but I just did 2 years there. So you can see it's going to keep repeating. So there's my sketch. So I took the data they gave me and I sketched a possible graph of what's going on, right? Now B says, find a possible formula for this population for time. So we're going to use P's and T's when we get all done, and that's important that you know that. So I'm going to do what I always do. Looks like amplitude, frequency, period, and midline. Now, when I do these, I always start at midline, and there's a reason for this because we're shifting everything out. So if I start at midline, I know midline is high plus my low divided by 2 because it's an average, okay? My high is 2,200, my low is 1,300, divided by 2 will give you 1,750, which is the line y equals 1,750. That's important that you know that, and if you put that in there, it kind of takes the guesswork out of doing these. So I have 1,750, all right? Before I start, though, I should have said looks like. What does it look like? And I see that I have my 1,750 right here, which is right between the 2 here. So I always put that in there. Then I look at this and I said, oh, wait a minute. Sine starts at midline, cosine starts high. Because this is not starting on that red line, it's not starting high either, it's starting low. So this looks like a inverted cosine curve, or we say negative cosine. Okay, so it's nice to do the midline and then see, does my function actually start on the midline? So then it takes sine out of the picture if it doesn't, and then you just pick which one it is. You really only have 4 choices, okay? So now that's my midline. My amplitude is high minus my midline. So this is work that I want you to show. So I'm making sure that you do this because sometimes people make goofy mistakes. 2,200 minus 1,750. So my amplitude is going to be 450. And remember, amplitude is always positive. Because I have a graph, we are going to do period first because your frequency is in your equation. Okay? So my period is how long does it take me to see one entire curve? I know I graphed 2 years, but in actuality, it only took me 12 months to see the entire curve, meaning I started low and ended up low again. So my period is 12 months, which equals 2 pi over my frequency. If I cross multiply or replace that frequency with 12, you get pi over 6. And now I can come up with my formula. My formula is my population is equal to, don't forget the negative, 450 cosine pi over 6 times time, which is your x-axis, plus 1750. There is a representation of what we just talked about. And that's kind of cool. I just gave you 2 data points and told you when they happened every year. Okay? Now let's look at and see what they want to do for C. C says, interpret the amplitude, period, and midline of this function. Okay? So the amplitude is basically, well, let's do the midline first. The midline is the average number of animals, isn't it? If I take the high plus the low divided by 2, I know that the midline is my average number of animals, okay? Now the amplitude basically shows you how high and low it goes above the average. So a lot of times people say, oh, that's the fluctuation of between the average of the year. So here's my average animals. It fluctuates 450 animals high and low over that average. That's what the amplitude does. The period basically tells me that it's a 1 year that this fluctuation happens between the high and low of all the animals here. So you kind of have a pattern for the animals in that area. Okay? Here is, so I get people who are pretty good with this. They can tell me the equation, so they're pretty good with that. They can explain it pretty good, but then D causes a little issue. First of all, D is, this is what you need to be in at all times when you're doing equations, is radians. I cannot stress that enough, okay? So they want to know, all right, find algebraically what 2 months in the year where the population is 1,500, all right? So the population is 1,500 is like in here somewhere, right? So we want to know when this is, kind of in this time it is. So it's like if we just look at 1 year, it's twice a year. Sometime between January and July, it's going to be 1,500. Sometime between July and, again, January, it's going to be 1,500. So that's great. You could graph it, come up with an answer, but I want to see the algebra. So let's practice that. So basically, we're going to take our formula, and in the P spot, we're going to put 1,500. So I'm going to say 1,500 equals negative 450 cosine of pi over 6t plus 1750. Now, those of you that I had yesterday, that we had a wonderful break outside because we had a fire drill, is basically I said, you guys have been doing logs. So you guys know I always say do normal math first. So the first thing you're going to do, because you know, you eventually want to solve for t is what you're trying to isolate. So the first thing I'm going to do is subtract 1750 on both sides because that's normal math. And when I do, I get, oh, I skipped this part. So 1750 would be minus 250 equals negative 450 cosine of pi over 6t. And then I got more normal math. I'm going to divide by 450. So when I take negative 250 and divide by 450, because they're hooked by multiplication, you actually get 5/9. Your calculator will actually do that for you, is what I get. Now, normally I do not reduce or anything, but the calculator did it when I divided negative 250 by 450. Now, here is no more normal math. Say that 10 times fast. So I got to say, okay, I have to solve for t. T is inside there, so the only way to undo a cosine is inverse cosine. So I've got to do inverse cosine. This is where I'll have somebody with perfect work have the wrong answer because they had it in degrees. So I say, thanks for playing. The inverse cosine of 5/9 equals pi over 6t. Again, we're in calculus. So instead of dividing by pi over 6, I'm going to multiply both sides by the inverse. So I have time is 6 over pi, or inverse cosine of 5/9. Now, when you put that in your calculator, you get t to be 1.875, which is great. It's great to know that. So I'm trying to figure out when that is. Now, remember, January 1st was 0, okay? So that means February 1st is going to be 1. March 1st is going to be 2. So when is that going to be? Well, it's going to be sometime near the end of February. So it's going to be sometime near the end of February is when it's going to hit that, all right? That's great for the first one, but then I got to find the other one, all right? So what you have to do is you come and look at this and say, okay, after I do this, it's 12 months and it's right before that. Don't use the 6, but use the end of the year because that's where it is. Take 12 and subtract that because it's on the other end of that. So if I take 12 and subtract the 1.875, you get 10.125, which if I kept going is November. So you have to be careful because you're used to November being number 11, but because we let January 1st be time is 0, just be careful. So that's sometime in November, okay? That's exactly how you do one of those problems, all right? I think I'm only going to have time for one more, but I think this is worth doing. So I'm trying to think if I'm going to do 10 or 11. Let's do 10. So let's go to the next one and practice this one more time. Okay. So here I have a company's sales are seasonal with a peak in mid-December. So that's December 15th is mid-December. Okay. And the lowest point in mid-June. So that's June 15th. Okay. So they make 100,000 in sales in December and only 20,000 in June. And this is kind of typical of a lot of companies because their sales are basically for December. And if you see them try to open up a business, they always try to open it up right before Christmas so they can get that big hit in sales. All right. It says now find a trigonometric function. Again, you get to make this look however you want to look. But I want you to be smart about how you do this. So we're going to do life is in quadrant 1. I'm only going to do 1 year because I didn't tell you what to do, so we're going to just do 1 year. So this is sales in dollars. This is time in months. And they said December 15th. So I'm going to be smart about this. Watch. Time is 0 is 12:15. That's important that you know that. Then I've got here June 15th. Okay. So that's going to be there. That'll be 6. And then here I've got December 15th again. That'll be 12. Okay, so we're just going to do 1 year. I guess I got enough room, but we'll just do 1 year. They said the sales were 20,000. It's my graph, so this is 20,000. And then I've got 100,000 up here in sales. And then basically you just kind of do the data. So December 15th was a high. June was a low. High. I could keep going, but we'll just do one curve for right now. Okay, so there is a representation of the data they gave me. Now we're going to come up with a formula, and we're going to use S for sales because it said S equals F of T, find a trigonometric function. So I'm going to say looks like, I know you have more room at the bottom, but this will save me from moving it. Amplitude, frequency, period, midline. Okay, so I start with midline. Always high plus low, so I have 100,000 plus 20,000 divided by 2, so that's going to be y equals 60,000 is my midline. You know what I always do is come up and make sure I did that right, so I kind of put that right in here. Y equals 60,000. Amplitude comes next. And then I look at this and say, oh, my graph does not start on my midline. So this starts high. So this looks like cosine. My amplitude is high minus my midline. So that's going to be 100,000 minus 60,000 or 40,000 is my amplitude, which is my fluctuation from my average. Then it's a graph, so I'm going to do my period, which is 12 months, which is very similar to what we just did, is 2 pi over my frequency. Flip their places or cross multiply, if you will. So I know it's my frequency is pi over 6. So my sales are going to be my amplitude, 40,000. Okay, cosine pi over 6t plus 60,000. I'm trying to check on the time, guys. Hang on a second. Okay, we're doing good. All right, so there's my equation. So I sketched it, and I'm going to tell you right now, guys, I don't understand why some of the questions, I try to fix them. They'll say, come up with the equation for it before the sketch. I never do that. I sketch it first, and then I come up with the equation. I'm very visual. It helps me, okay? Now it says, what would you expect the sales to be for mid-April, okay? Now, mid-April is 4/15. You got to remember, we let t equals 0 be 12/15. So literally, I go through and figure out what number do I put in. So I know 12/15 was 0, time is 0. 1/15 is 1. 2/15 is 2. Get the idea? 3/15 is 3. 4/15 is just a 4. I don't need to put 4.5 in there. I just put a 4 in there. So I do sales is going to be 40,000. So you show me this, cosine. And all I'm going to do is plug a 4 in there. By doing that, and I'm in radians, will tell me what the sales will be then, okay? And my graph is a sketch, but I'm assuming, I didn't put this in my calculator, I'll let you guys do that. But when you put that in there, I know the sales are going to be somewhere like heading on the way down, because this is June 15th, so it might be closer to 20,000 than it is 100,000. So you just throw that in your calculator. Make sure you put this multiplication, make sure you're in radians, and you'll come up with your sales, okay? And the last thing we're going to do is the one that causes people a little pause. It wants to know find the 2 times in the year that the sales are 60,000. So that means I'm going to put my equation equal to 60,000. So here's D. So I got 60,000 equals 40,000. Oops, I forgot cosine. That would be nice. Cosine pi over 6t, because I'm solving for t, plus 60,000. Again, do all your normal math first. All right. So when I subtract 60,000 from 60,000, I get a whopping 0 here, because I'm doing normal math. And then if I take 0 and divide by 40,000, I get another whopping 0, which makes our equation pretty nice, pi over 6t. Now the t is inside, okay? So I have to inverse cosine both sides. Thanks for playing. Inverse cosine here. So the inverse cosine of 0, okay? So when I go through and solve this, the inverse cosine of 0, so I'm thinking, what is that? So I'm going to do the inverse cosine of 0, okay, equals pi over 6 times t. So t is going to equal 6 over pi times the inverse cosine of 0. Okay? And all of you should know what the inverse cosine of 0 is, so that you can plug that in your calculator. You'll see what you get to. When you do this, t is 3. So you put that in your calculator, and then you get time is 3. So the 2 times a year that's going to happen is March 15th, because that's when time is 3. And the other time is going to do 12 minus 3, or 9, or that would be September 15th. Okay? So I'm trying to see what time it is. Okay, so it's getting close to the end here, guys. So I'm going to actually stop recording this in a second here. Let me get to here. And then I'll ask if there's any quick questions. Oh, I don't know if I am recording. Yes, I am. Hang on a second. Everybody's so loud in the hall because they just asked.